Hello, everybody. Happy Monday. Uh, Today we are going to be kind of getting back into our climate change unit. I thought really hard about whether or not to have a place where we could at least have more of a discussion about George Floyd and the rioting that's been going on in the Twin Cities and people coming in from out of states to riot and things like that and just all of the wrongness that is happening right now. Um, and I kind of came to the conclusion that you guys probably already know just about as much as I do. And if not, you have the ability to find that information. Whereas with climate change, this is something that I'm particularly knowledgeable about, and I know things about climate change, things that you really should know, things that are really important, that I can teach you right now while I still have these last couple of days left. And I don't want to sacrifice the time that we have and miss this opportunity to teach you guys some really incredibly important lessons. And so that's what we're going to be doing. For the next 2 to 3 days, we're going to be talking about climate change and just, effectively what's happening with it. I've kind of titled this PowerPoint series as Climate Change, the Past, Present, and Future. Today we're primarily going to be talking about climate change in terms of the past and in terms of the present. And tomorrow we'll be talking about it in terms of the future and getting into what we can do about climate change. The target for today is to be able to identify how the amount of greenhouse gases has changed in our atmosphere over time. So, if we are going to do that, we need to be able to measure the amount of greenhouse gases. How do you measure a gas? I mean, do you measure it by the room? Do you measure it by the lungful? I mean, you can't really put a gas on a triple beam balance and figure out how many grams of gas you have. So, how do scientists actually measure gas? We use something called parts per million, or ppm. Basically, let's just say there's a million air molecules right here. The parts per million is telling me how many molecules in that million are of a certain type. For example, let's say we have a ppm of 350 CO2. What that means is that in this million molecules, there are 350 molecules of carbon dioxide. How do we get this information? Basically, we have these fancy machines that suck in carbon dioxide and it counts the number of molecules and it can also identify what those molecules are. So the fancy machine sucks in the gas, measures the molecules, and we want that reading to say 350. Okay, so how much CO2 is a healthy amount of CO2? We'd like it to say 350. Heck, we'd like it to be below 350. But scientists have said that if we can get the amount of carbon dioxide into around the 350 parts per million range, we'll have a healthy atmosphere. If we can get it even lower, it's going to be even better up to a certain point, right? Currently, we have 416 parts per million of carbon dioxide in our atmosphere, and I can show you where I'm getting this data from. This data is coming from the Mauna Loa Observatory. Oops, there we go. The Mauna Loa Observatory in Hawaii. The reason this location is chosen is because Hawaii is very far away from factories, from other countries, from potential sources of pollution. And so this is giving us a very good average indication of how much carbon dioxide is in the atmosphere as an average. There may be some places in the world where there is more carbon dioxide. There may be some places where there is less. This is in part based off of the amount of pollution that a city or country or state is producing. But as an average, we've got 416. We want 350. Okay. There we go. So how do we know how much carbon dioxide is in our atmosphere? Firstly, the past 60-ish, 70-ish years, we've been using that fancy machine I was talking about before, and that's been sucking in gas and taking measurements every single day for the past 70 years, telling us how much carbon dioxide is in our atmosphere. But what if we want to know how much carbon dioxide was in our atmosphere 100 years ago, or 10,000 years ago, or 100,000 years ago? How do we do it? Well, we use a technique known as ice core sampling. And this is groundbreaking technology. This is really proving how serious of an issue climate change is. Because I've told you, we've got 416 parts per million, we want 350, but how big of a difference is that? Right now, I'm giving you numbers, and those numbers don't mean anything because they're taken out of context. So if we can use ice core sampling to see what is the context of the amount of carbon dioxide in our atmosphere over the lifetime of the Earth, like how much has the Earth had as a maximum, as a minimum, compared to how much does it have right now? Ice core sampling allows us to learn that. This is really powerful technology. So how does it work? Okay, so if you guys think back to 8th grade earth science, you might have talked about something called sedimentary rock. Sedimentary rock basically forms in layers. You've got maybe a sandy beach, and one day, the ocean kind of comes in and it pushes up a bunch of rock onto the beach. And so now there's another layer of dirt on top of the pre-existing dirt. And then a nearby volcano erupts. And so now there's more dirt on top of the dirt. And maybe there's a earthquake or something, and the tectonic plates shift. And so now there's more dirt on top of dirt. And basically the dirt just kind of keeps forming layers in a process known as sedimentation. Process of sedimentation also happens with ice. Ice forms layers. Older ice is towards the bottom of Arctic ice sheets and towards the bottom of glaciers. And newer ice is closer to the top because it's just snowed on top of it, right? But what scientists can do is we can drill down to that really deep ice, and we can measure the amount of carbon dioxide that was trapped in that ice when it formed. And this allows us to know how much carbon dioxide was in our atmosphere a long time ago. And this is crazy information because now we can start seeing trends, we can start seeing patterns, and we can start analyzing how much of this is our fault. How much has the amount of carbon dioxide changed since humans really started pumping carbon dioxide into the atmosphere, since we really started burning coal and oil, since we really started this population boom of now 7 to 8 billion people, right? So let's take a little bit of time and just analyze how has the amount of carbon dioxide on our planet changed. Okay. The past month and the past 6 months, there's really not a whole lot of growth. In both of these pictures, we're seeing that the carbon dioxide amount is changing slightly, but I think we'll get a better scope of it if we're looking at a more longer term. So let's kind of jump into a year. One thing that is important to note is that the amount of carbon dioxide in our atmosphere fluctuates a little bit, and it fluctuates with the seasons. So during the spring, summer, and also fall, trees are photosynthesizing. They're sucking in a lot of carbon dioxide from the atmosphere, as are plants. Bushes and grass are doing the exact same thing. But during the winter, not a whole lot of photosynthesis is happening. And so people are still producing carbon dioxide, but the environment isn't sucking it back into our carbon traps. Our forests, they're not able to do their job because it's winter. So you might see a couple of little dips in a couple of these upcoming pictures. For example, if we look at just the past record, so the past record is basically the amount of time that we've been sucking in carbon dioxide with the machine. So this isn't using the ice core sampling. This is just using machines, taking measurements, measuring carbon dioxide with these special machines, how much is in our atmosphere. And this is where we can really start to see a lot of interesting things. First of all, we can see every single year there is an up and a down, right? With the seasons, the amount of carbon dioxide is absolutely fluctuating. But boy, we've got 100 more parts per million carbon dioxide in our atmosphere than we did before. Like, the amount of carbon dioxide has grown dramatically over the past 70 or so years. We haven't had a healthy atmosphere since the 80s. Oof. And it's still going up, right? I mean, We've had environmental revolutions where people are like, hey, let's replace light bulbs with LED bulbs. Let's take shorter showers. Let's, use less electricity. Let's burn fewer fossil fuels. But the amount of carbon dioxide that we're producing is still going up. And if we actually look at the past 300 years, there we go, we can see that the rate that the amount of carbon dioxide is being produced is also going up. So we are burning fossil fuels faster than we were before. And this is continued to go up. It's actually been really crazy. As a teacher, this is a lesson that I've taught every year since my first year of teaching. I had a classroom at Bold, and half the class didn't actually believe climate change was happening. And that's kind of what led me to start teaching these lessons, was the fact, and that's not something I've seen a whole lot at CPA. Students at CPA think that climate change is happening. Good. But they don't know how or why. And so that's really what I've been focusing on while at CPA. And that's where this data really comes into place. It's showing us how climate change has changed over time. Because as we get more carbon dioxide, the temperature goes up. So this is still a relatively small time scale. I think a question should be raised. It's a very valid question. Maybe this is just a natural cycle in the earth. Maybe the earth is just, it's exhaling right now. This is just a natural part of the process. This isn't man's fault. This is just what earth does. That's not true. Here's how we know. It's because of ice core sampling. We can see how the carbon dioxide has changed for thousands and thousands of years. So let me help you just understand this graph real quick. First of all, carbon dioxide, right? The higher the value is on the graph, the more carbon dioxide is in the atmosphere. So if we're going back 800 or 700,000 years, we can see that typically we've got somewhere in between 200 and 250 parts per million. Whenever it dips down to like below the 200 range, that's an ice age. So we actually had an ice age about 10,000 years ago. There was an ice age about 10,000 years ago with woolly mammoths and things like that. And that was because the amount of carbon dioxide was below 200. Sometimes it goes up to as high as, frankly, almost 300. But never in the past 800,000 years has the amount of carbon dioxide in our atmosphere been as high as it is today. And if we look at the graph, this little line right here is representing the past 100 or so years. That's crazy. That's an incredible amount of increase. That's so much growth. The slope on that, you can't even measure it in this graph. It's so high. We are creating so much carbon dioxide compared to what was in the atmosphere forever. We have completely changed the ecosystem of our world, and we need to fix it. Because if we don't, really terrible things can happen. And we're going to get into those terrible things more tomorrow. But coronavirus is in part due to climate change. See, as temperatures get warmer, the ability for viruses to mutate increases. And so the fact that coronavirus has happened is partially because of climate change. In addition to virology increase, like coronavirus, desertification, large population movement, the ocean sea levels rising, causing flooding, tornadoes and hurricanes increasing both in size, density, and number. These are just a few of the problems that climate change is going to cause. Species populations, it's crazy to think about it, but we are actually experiencing the sixth great mass extinction. Like 90% of species are dying right now. And climate change is having a really big role in that. We're going to be getting into that a lot more tomorrow. And we're also going to be talking about what can we do. It's really hard to think about these crazy big things like mass extinctions and rising sea levels and figure out what the heck can we do to solve them. But there actually are some really big things you can do to help the climate. Stay tuned. See you later, folks. Bye.